Hello and welcome back to new episode of Foreknowledge. In this session, we are going to discuss about the Leibniz rule for differentiation under the integral sign. Okay, this is a very important topic with respect to JEE mains and other engineering entrance exams. Okay, each and every year they are repeating questions from this topic. So I am going to discuss this today. So what does it say? First of all, we need to know the statement. It says that there should be two functions. There should be two functions gx and hx. Okay, defined on a certain interval ab. Defined on a certain interval ab, and both the functions are differentiable at a point x belongs to open interval ab. Okay, and ft is continuous on closed interval GA to GB. Okay, this is the prerequisite for the rule to be applicable. This is the prerequisite for the rule to be applicable. Fine. Now look, what is the rule? Then differentiation of integration gx to hx ft dt. Fine. Look, the name. The name says the Leibniz rule for differentiation under integral sign. Okay, here is the integration. We have to differentiate it. Okay, so this is the Leibniz rule. Now what does the rule say? The rule says if these conditions are satisfied, then this differentiation will lead us to the result that f of hx into derivative of hx minus f of gx into derivative of gx. This is what the Leibniz rule says. This is what the Leibniz rule says. So once again I am repeating this. ddx of integration gx to hx ft dt equal to f of hx, that means f of upper limit into derivative of upper limit. Fine. Minus f of lower limit into derivative of lower limit. That is what the Leibniz rule says. Okay. So if these conditions are satisfied, then this is the Leibniz rule. Now one thing I can guarantee you that you need not verify these conditions in your JEEMains or other engineering entrance exams, because they will give the problem in certain way that these conditions are already pre-verified. That's guaranteed. Fine. So you have to focus on the formula itself. You have to focus on the formula itself, how the thing is happening. Fine. So if this is clear, if the formula is clear, then I am going to solve some problems on this topic. Let me erase this. I am just keeping the formula and the statement I am erasing. Now let us solve a problem first. Then it will be clear to you. The problem says evaluate ddx of one by x to root x, 1 by x to root x cos t square dt. This is what we have to evaluate. Fine. So let's get back to the formula. Let's get back to the formula first. Now look, ddx of integration up to this part is clear. Now what is gx? Gx is 1 by x. This is your gx. What is hx? This is the upper limit, This is the hx. And what is ft? Ft means cos t square. Cos t square. So just apply the formula. Just apply the formula. That means f of upper limit. That means cos of upper limit. So cos of upper limit means root x square, cos of root x square into derivative of upper limit. Derivative of upper limit. ddx of root x minus f of lower limit. That means cos of 1 by x square into derivative of lower limit. Simple. Cos of upper limit into derivative of upper limit minus cos of upper limit into derivative of cos of lower limit into derivative of lower limit. So if we simplify this, this is nothing but cos x into, what is the derivative of root x? This is nothing but 1 by 2 root x minus cos of 1 by x square into derivative of 1 by x is nothing but minus 1 upon x square. Minus 1 upon x square. Look if this is clear. Now just simplify this. The answer will be, I am writing down here. 1 by equal to 1 by 2 root x cos x. This minus will bring us a plus 1 by x square cos 1 by x square. This is your answer. This is your answer for the question this. Now if this is clear, let us solve one previous year JEEMains question. Shall I erase this? Fine. Now the question says limit x tends to 0 to x t sin 10t dt divided by x equal to, there are four options. Number 1, it is saying that 1 by 10 minus 1 by 5, 1 by 10 minus 1 by 5, that is 0, third option, and fourth option is minus 1 upon 10. How do we approach the question? Look, if we put the value here, what is the limiting value? The limiting value is 0. So if we put 0 here, then the denominator is 0. Fine, denominator is 0. And if we put 0 here, then 0 to 0, a definite integral, what happens? A definite integral from a to a, what happens? The definite integral's value becomes 0. Okay, so this is nothing but a 0 by 0 form. This limit is nothing but a 0 by 0 form, and we can apply L'Hospital rule here. Okay, we can apply the L'Hospital rule here. That means nothing but differentiation in the numerator, differentiation in the denominator, and the differentiation in the numerator is leading us back to this form. Look, ddx of the numerator, same as the formula written here. Got it? Let's begin. So this is equal to limit x tends to 0. So ddx of, I'm just writing down the differentiation part for your convenience. There is no need to copy it again if you are convinced what I have explained here. Okay, so now this is the case. sorry, ddx of x. Fine. Now look at the formula, apply it. So this is equal to limit x tends to 0. So what is the upper limit here? X. So f of upper limit, f means t sin 10t. So x sin 10x into derivative of upper limit, that means derivative of x. Derivative of x is 1. Simple. Minus f of lower limit, that means 0. 0 into sin 0, that means 0. Okay. So there is no lower limit part. So x sin 10x whole divided by, what is this? This is 1. Fine. So now the part is clear. So just put the value. So 0 into sine of 0, that is nothing but 0. So option 3 is correct. Option 3 is correct. Just go through it, and if it is not clear, then again pause the video and watch it. Copy it down. Copy it down. I hope this is clear. Simple. F of upper limit, so x into sin 10x into derivative of x, that is 1, minus f of 0 lower limit, that becomes 0, and the denominator is already 1, so just put the value, the entire thing is 0. This was the previous year question. I hope you understood the problem. So we have discussed about Newton-Leibniz rule, and we have discussed 2 of its problems. Okay. So now I think if you encountered this type of problem in your JEE Mains or other engineering entrance exams, then it will be a very easy for you to solve the problem. Okay. So just if you like the video, please subscribe our channel and let us know how you feel about the video. We'll be meeting in our next video. Thank you.